Hello again, all you fellow scientists. Welcome back to STEM with Mr. C. So this is part two. You see I have already, look at this, already have some liquid set up. Part two of our litmus strips are testing acidity and bases with red cabbage. If you remember last episode, we took a whole hunk of red cabbage, chopped it, diced it, threw it in some water, boiled it for about 20 minutes, and then we were left with this wonderful purple liquid. And then we used this purple liquid and we dipped coffee filters in it, let them dry, and now we have these wonderful litmus strip testing devices. Pretty awesome. If you missed that episode, if you missed part one of me chopping up cabbage and making a big mess, you're probably going to want to click up there. That's right. And so now that you have your litmus strips, I have obviously a whole bunch of these. We can now test the acidity of different liquids. We can test whether or not a liquid is an acid or a base. Now remember, let's go ahead and throw our pH scale up on the board. Right there, there's our pH scale. Remember, pH per hydrogen or potential of hydrogen. Quick review, if it's an acid, that means it loves to give up protons or charged hydrogen, right? Loves to give up hydrogen, loves to. So the lower the pH, 3, 2, and 1, the stronger that acid is, the more acidic it is, the more willing it's going to give up that hydrogen, right? That hydrogen ion, that proton. If you're a base, that's a higher number, 10, 11, 12, 13, 14. That just means your willingness to receive that hydrogen or that proton, that charged hydrogen. And so the stronger the base, the higher the number is. And water, our friend water, should be a pH of 7. That's neutral. That means it's not acid, it's not a base, it's just right in the middle, very happy. And so we're going to test some different liquids here, right? And then after this, we have 3 mystery liquids. Ooh. Right? And what's cool is they're going to all be clear, which, like, not clear as in understand, as in clear as in can't see through them, as in no color. I think you guys know what I mean. And that's going to really stress why it's really good to have testing equipment instead of like tasting it, right? We've already talked about acids are very sour, right? If you've ever bit into a lemon, very sour. Bases are generally slippery. But again, we don't want to go around tasting these things because they can be very dangerous. Okay, for this lab, it's really easy. All you need is your litmus strips, however many you have, and just some random liquids around the house, whatever you want to test. I don't care. You want to test orange juice? Do it. You want to test milk? Go ahead. Blueberry juice? If you have some, cool. Whatever you want to test. Cleaning stuff. Obviously, ask your parents, your guardians, your aunt, your uncle, your grandma, your grandpa for permission before you start playing around with cleaning stuff. But ask them, say, can we test different things around the house? You can even test your own spit, which is going to be pretty cool.
Ew, no, David.
If you want to do that. Okay, so we're just going to jump right into this. And now we've talked about the pH scale. And really, we need to know, we have a purple strip here, right? So if it's purple, what does that mean? And what's going to happen if we dip it into these liquids? Because they're going to change color. And we're going to talk about why it does that. But we need to know what that means, right? If we just know they change color, that doesn't mean anything. So we have to understand when it changes a color, that's going to tell us whether it's an acid or a base. And it's even going to tell us how strong that acid or base is. And that's the important thing, right? Obviously, we want to know if it's an acid or a base. But if we're scientists, we need to know how strong that acid or base is. And so, and I'm going to put a little color scheme up here for red cabbage. It's going to be right up here real quick, and then we'll refer back to it. But so if we use red cabbage to test acid or bases, these are the colors that you're going to get. And so from, if it's an acid, pH 1, 2, 3, 4, and 5, it's generally going to be from 1 to 5, right? Orange, like a dark red, orange, red, dark pink, pink, light pink. Okay, if you're in the middle, right, if you're neutral, 6 is going to be kind of violet. 7 shouldn't show any change. It should just stay purple. And then 8's going to kind of be a light purple, almost like a bluish sort of thing. And then if you're a base, 9, 10, 11, 12, it's going to be blue, aqua green, yellow, and then it goes up from there. I don't think we have anything that's a pH of 14, hopefully. But those are the colors we can refer to. So we get an instant feedback of testing our litmus strip, looking at it and going, oh my goodness, that's a base. And it has a pH of whatever it is. All right, so let's do the first one. And I've got milk, water, this Clorox cleaner that we use at school. It's this simply green. It smells wonderful. It really does. I think it's Clorox cleaner. And then we have coffee. And so we're going to determine what is acidic and what is basic, or what's going to happen. And at the end of this, we're going to bring out 3 mystery liquids, and then we're going to test them. So let's do the first one here. Let's go ahead and take my litmus strip, and let's just start off with water. Okay, water is a good one. So let's just go ahead. All we have to do, if you have an eyedropper, you can always drop it on there. But I've got small cups here, so I can just dip it in there, right? And let's take a look at what we have. So sure enough, right, that is going to be nice and basic. No, sorry, that's not basic. That's neutral. I meant to say nice and neutral. It's neutral, right? So this is our water, straight from the tap water, didn't change color, and so that's good, right? So we can look at this and go, and I'll even put it up against some white paper so it's a little bit easier to see. Let's go ahead and do that. And there we go, look at that. We can test that and we can go, yep, no change, that's nice, look at that. That is neutral, pH of 7. So good, we know our water is not acidic, it's not basic, it's nice and neutral. That's good, go put that right there. All right, let's go on to, I don't know, what are we feeling? What do you guys think? Think the milk? All right, I agree, I was gonna do the milk next. All right, so let's go to milk, and let's take a look. All right, get that milk. It's actually half and half. Gonna be kind of the same. Let's see what we get here. Sometimes it does take a minute. And let's see, we're not getting too much of a change. Let's go ahead and take a look here. And let's see. Okay, so this is kind of not really anything at all either. This is kind of neutral. It's interesting, right? Some milk, right, can be slightly acidic, and that's due to the lactic acid. Okay, we'll let that sit for a little bit. Interesting. All right, let's go on over to our Clorox cleaner. Clorox cleaner, we should absolutely get some sort of color change. And it looks like, oh yeah, getting it. Oh, there we go. There it is. All right, yes. Yes. There. You can see blue, right? That's blue. I know it doesn't really look like it, but as I put it in, I can actually see it being blue. And there we go. Get that. There we go. Look at that. Nice blue. We can see the difference, right? Purple, blue. So now we know that our Clorox cleaner is actually slightly basic. Okay? Look at that blue. You can even see that liquid right there kind of dripping down. That's basic, right? So our cleaner is basic. Very cool. Look at that. All right. Nice. And again, if you're expecting like this bright blue, this like in-your-face blue, it's kind of subtle, right? You do have to look for it. So let's go over to our coffee, and let's take a look. Oh yeah, look at that. So that, look at that color, right? That's almost that's like a red. Now I know you're thinking that's probably the color of the coffee, right? No, that's the acidity, right? So it's not the brown in there. It's actually in there. I'm holding see the purple? So you see that changed it to like a nice, kind of like a pinkish right? So that's going to be acidic. So our coffee is going to be slightly acidic. I also used a lot of coffee. And so that gives us a nice red, which is cool. Remember, red, it's actually not red, it's more of a, let's look at it, like a, I would say like a light pink, and I can test another one. It's gonna be like a light pink. So it's, again, this isn't like super acidic, but we can kind of see, all right, just right there. Another piece of paper here. There we go. Just like that. So you can see it's, again, it's real subtle, right? It's kind of like a light pink. Very nice, kind of like a light pinkish right there. And so that's going to tell us that it's also slightly acidic. All right, excellent. And so those are our known liquids, and a lot of them make sense. Now the longer this sits, now you can really see this kind of turning blue. You can really see that blue pop out there. Look at that. And the longer it sits there, we can even let it sit in there. Water still neutral, and then our coffee is still, and then even our even our half and half, right? I mean, maybe like a lightish violet, so maybe slightly acidic. Obviously it did change a little bit, but obviously not that much. Okay, so that is pretty cool. All right, so now we're gonna go ahead and clear this out, and then we're gonna put up our 3 mystery liquids, and then we're gonna determine whether they are acids or bases. All right, everybody, thanks for sticking with me. And I've set up our 3 mystery liquids, and they all look very much the same. So this is mystery liquid number 1, clear, right? I'll show you. Bring up my little white background here so we can see. So there you go. Clear. Okay. And then we have our second one, also clear, which is interesting. And then we have our third one, and it looks like I have a little, there we go, clear as well. And so this really stresses the importance of testing these things. Right now, I know what they all are. I know I could drink or sip all of them, and they're not gonna hurt me. But that's not always the case with chemicals that we come across, right? So we don't wanna go touching and tasting things if we don't know what they are. Especially in science or chemistry, that's generally a bad idea. Okay, very rarely does it turn out, it's never like a delicious treat like, oh, what's in this beaker? Oh my goodness, it tastes like cotton candy. That's never really happened to me. And no, I don't go around tasting random chemicals. So, okay, so let's go ahead. Remember, we've got our, let's go ahead and put our cabbage pH scale up here one more time. Okay, so again, pH 1 to 4 and 5, right? Orange to red. So anything like in the reddish or pinkish is going to be an acid, okay? So the darker the red, the stronger the acid. 6, 7, 8, you know, neutral, you've got violet, purple, kind of like a lightish blue, purple, and then 9, 10, 11, 12, 13, 14, then that gets into the blue, aqua green, yellow, and then really yellow, okay? And so here we go. Let's go ahead and start with mystery liquid number 1. Okay, and then we go ahead and pop it. Oh, woo! That did not take long at all. Bam! Look at that. Bam! Look at that. That's like a probably, I would even say pink, dark pink. Woo! That is strong. Look at that. That clearly is an acid. Yeah, you all wanted like, I want instant results. Boom! Look at that. That is amazing. Okay, that's going to be a pH of 4. I would say this is like a nice strong pink. I could even go with a pH of 3 maybe. This is very strong. Okay, and I'm going to put it. I'll leave it in there. Cool. That is pretty awesome. Okay. Wow. Okay, let me move it back so you guys can really get that. That's awesome. Okay, and next we have this one in the middle. So we know that's an acid. I'm going to tell you what it is at the end. And here we go, mystery liquid number 2. And let's go ahead and leave it in there a little bit. And I'm actually kind of sad about this because I was actually expecting something a little more. I actually did kind of a product test here. I went to the store and I'll tell you why. You know what, that actually disappoints me, really. That really disappoints me. I'll tell you why. It's not a failure, it's just, meh. It's like, I'll tell you guys why. So I didn't really do anything. I mean, it's maybe, I don't know, what do you guys think? Let's see what you guys, tell me at home. I think it didn't really do anything. And we'll compare, right? I don't think it really did anything. No, didn't do anything. So we're gonna say neutral. And that's kind of saddening, right? That really saddens me. I'll tell you why it does. I know I keep saying that. All right, last one. We've got this stuff here, and let's go ahead and drop it in. And this is, we're giving a little, I would say a little bit of light, maybe lightning, maybe violet even. So it's definitely gonna be lighter than the purple that we used. Okay, definitely lighter than the purple, a little bit. So I'd probably put this at a pH of 6, which kind of makes sense. So it's slightly acidic, not that much. Okay, so if you want to know what these were, okay, this one on the left, this was nothing more than just sparkling water, okay? And so it makes sense that it's slightly acidic, pH of 6, right? That makes sense because carbon dioxide, when you do add it to water, it does actually, that's one of the things that creates acid rain, okay? Or it actually causes acid rain. So a lot of carbon dioxide in the water will make it slightly acidic. Now, obviously, this isn't that acidic. This is I mean, this is like a violet. Yeah, I mean, so this is going to be like a pH of 6. So this is, I mean, it's okay to drink. Okay, so this is actually, okay. It's actually kind of, you can kind of see. All right, so I'm not as upset as I was. You can kind of see the temperature. Okay, so the difference. All right, so I'm not upset anymore. I was actually very upset. So it's kind of blue. So this would give it like a pH of 8 or 9. Okay, so I'm not upset anymore, and I'll tell you why. I just really couldn't see it on the litmus test. So sometimes you do have to let it go. All right, okay, and I was gonna get upset because this is this smart water. It's this is a thing you guys have probably seen, right? They market the whole alkaline pH, supposed to hydrate you, and it's not acidic, it's pH of 9. And I thought it's just like, yeah, okay, whatever. So I wanted to test it. And so that's kind of what I do, is I go there and I don't believe what they advertise to me and I want to go and test it. And sure enough, I mean, that does have a pH of probably 8 or 9. It's really hard for me to tell without more accurate testing, but okay, so they're not just selling me water that they got from the garden hose at home. This actually does have a little more basic feel to it. Okay, so I'm not upset anymore. Good. And this is just citric acid. So I have citric acid with like super strong lemon juice. So I have granules of citric acid, and I made it super concentrated. And so this is going to be a nice pH of 4, even 3, which is pretty cool. So yeah, that kind of makes sense because I made it extremely strong. But citric acid, right, you can just buy, and you can use it to, we use it in canning. It also prevents like bacteria. Citric acid is great for like canning and preserving. So look at that, that's pretty cool. Okay, I'm gonna do one more thing, and I've got cups of water, and I still have this this liquid here, and so we're gonna kind of do a little test just to have a little fun. If you have any liquid left over, it's always a lot of fun to do this. And woo, that's still, yeah, that still smells like cabbage. Woo.
Ew.
All right, I'm gonna be right back. All right, everybody, just a real quick last thing we're gonna do just to show you how fun this can be. So we have the strips, and so I'm pouring this, my mystery liquid. I know what it is. We've already done this, but it's more just having a little fun. And pour my mystery, well, you can actually see it's my alkaline smart water. I'm actually very happy that it actually did turn blue. I was going to be kind of annoyed by that. And then I've got my sparkly water, and we'll just see. And the cool thing is, I'm going to go ahead, there we go, about equal amounts. And then we're just going to go ahead and pour. So we have purple, right? Our purple liquid. Let's pour it in there we go. Pour it in here. Woo, look at that. And pour it in here. Wow, I mean, that is pretty cool. I add a little bit more here. You can actually see, there we go. You actually see very well. Look at this, see this difference. I think I need to add more here. And look at that, that is fairly impressive. So we've got our citric acid here, and this is, I made it extremely concentrated. And so this really, we can kind of see, I would put this almost like dark pink. I wouldn't put it at red, but this is extremely strong. I made this acid extremely strong. And this is our alkaline water. So this is gonna give us this, I mean, it's purple, but add a little bit more here. And you'll see it will turn slightly blue, which is very, I mean, I thought it was very cool, right? There it is right there, our slightly blue water. And so that's pretty cool. You can kind of see the difference. And this didn't really change much. This kind of stayed a little violet. So again, very kind of different. All three reactions are very different. Very cool. Okay, so that about sums it up for us. So real quick, the cool thing about red cabbage, it has this dye in there, this pigment, which is what allows it to change color when it reacts with acids or bases. And so that is why red cabbage is an excellent source to make pH strips. And the cool thing, the name of this pigment, they're called the family of anthocyanins, and that's what gives vegetables and fruits, you know, that purple color, that nice, you know, red cabbage color. So it's a family of anthocyanins that react to acids, bases, and then if they just kind of stay, this is still a kind of a, it's kind of, I like that one. But if they stay the same, then that's a good pH of 7. That's a neutral indicator. So we just made pH testing strips. So if you want to try this at home, remember, you got to do the first one. You got to make the pH testing strips using red cabbage. Soak them in coffee filters. Soak the coffee filters in the red cabbage. I wouldn't do it the other way. And then go around the house, test different things. Test your tap water, test your spit, test juice, apple juice, whatever you want to test. And see if you can figure out what is an acid, what is a base, and even if you can figure out what pH it is. All right, that about sums it up for me. This has been STEM with Mr. C, doing a little bit of chemistry here. And I look forward to seeing you guys next time on more STEM with Mr. C. Here's the citric acid. Let's, yeah, ooh. Yeah, that is sour. I know what it is, so I can do that. Oh, I made that really strong. That explains why it's so strong. I better go brush my teeth now. Oh my goodness. All right. See you all later.